Okay, you've got regular hexagon A, B, C, D, E, F inscribed in circle Q. I didn't show the Q as the center of the circle. And you want to prove that triangle BDF is equilateral. Several ways to do the proof. Here's one way. Okay, we've got regular hexagon A, B, C, D, E, F. That's given. And then you probably have a theorem that says the sum of the interior angles of a regular polygon is the number of sides minus 2 times 180, which would give us 4 times 180. And since it's a regular, in this case hexagon, divide by 6 to determine the measure of each congruent interior angle. So it's 4 times 180 divided by 6 is 120. That's where this 120 comes from. So this angle is congruent to this angle is congruent to this angle. And then it's also true that all of these sides have the same length. That's the definition of a regular, in this case, hexagon. All the sides are congruent. So these three gray triangles are all congruent by side, angle, side. Two sides and an included angle. So there we have the three triangles mentioned as congruent. And once we've established that, we can say that corresponding parts of congruent triangles are congruent. So the third sides have to be congruent by CPCTC. And once we have those three sides congruent, you can say triangle BDF is equilateral. Definition of equilateral triangle. Triangle with three congruent sides is equilateral. And QED, that which was to be proved. Forgot that period there. Okay, there you go. Hope that helped. If you have any questions, post a comment. By the way, another way to do the problem would have been to show that these angles right here had measures of 30, and 30 plus 30 is 60. 60 from 120 means that this is a 60-degree angle. You could have done that at each vertex and said that this triangle is equiangular, and then use the theorem that if a triangle is equiangular, then it is also equilateral. That's another way to do it. Okay, there you go. Again, if you have any questions, post a comment.